Hi, in this problem a child is walking on a boat and the boat is moving in the water, and we want to think about how the child is moving relative to the water. So I have this north, east here, and I draw a boat, kind of a crude looking boat here. So my child here is moving in this direction, my boat is moving in this direction. And so I could think of east as the x and have the y there. So we know the velocity of the boat on the water is, well, it's 16 north, so I'm going to say is 16j. It's a vector. And the velocity of the child on the boat, well, it's in the x direction at 4 miles per hour, so it's 4I. And these are going to add. So the velocity of the child on the water relative to the water is going to be 4I plus 16j. Right? So you get the picture here. And maybe instead of on, I should have said relative. So what's the speed? The speed is magnitude of velocity. And here for the speed of the child is going to be square root of 4 squared plus 16 squared, or square root of 272. Okay, so that answers the speed of the child relative to the surface of the water. Now, what about the direction? So if I draw this now, and here's my east is x and my north is y, and here's the direction velocity vector here. So this is 4 and this is 16 and this is theta. Well, so this is theta here too. So the tangent of theta is going to be 4 over 16, which means, so I'm finding the direction of the child as an angle off of the north axis. So theta here is going to be the arctangent of 4 over 16, which is about 0.2449786 radians. And that's that.